Hi guys, and as you can see in this video, I'm using a Class D PAM 8610 module. I like it because of its low noise capabilities and small size, as you have seen at the start of the video. Well, this video will be about filters, and a section of it will be looking here at passive filters, which I will talk about high pass and low pass filters. A low pass filter is a filter that only allows low frequencies to pass and blocks high frequencies. While low frequencies and high frequencies are relative depending on the circuit that is being designed. Now let's talk about a capacitor a little bit. A capacitor can be seen as a frequency controlled resistor. The resistance of a capacitor is seen at its reactance to a signal, and its reactance depends on the frequency that is being applied to it. Now we got this information, we can now understand how the low pass filter works better. Back to the low pass filter circuit. When, let's say, an audio signal with different component frequency is applied at the input, it passes through the resistor and gets weak. This is important for the ease working of our circuit. Now this same signal goes to the capacitor unchanged but reduced in its amplitude. The reactance of a capacitor is inversely proportional to its input frequency. So some of the component frequencies go straight to the output because those frequencies are relatively low, so the reactance to them is very high. But the other higher component frequencies makes the capacitor to have a lower reactance, so they flow through the capacitor and get shunted to ground. With the help of the resistor reducing the strength of the signal, the capacitor can shunt frequencies more accurately. This is the basic theory of low pass passive filter. Now over to the high pass filter. We now know the behavior of a capacitor to frequencies applied to it. The high pass filter circuit is as simple as this with just two components as a low pass filter, but this time the opposite in terms of operation of a low pass filter. Okay, the same audio frequency component is applied to the input. Since the capacitor's reactance is inversely proportional to the frequency applied to it, when a lower frequency than its cutoff frequency is applied to it, the reactance is high and the signal doesn't appear at the other terminal of the capacitor. Now, if a frequency that is slightly close to its cutoff point is presented at the input, the reactance of the capacitor goes low and a weak signal becomes present at the other side of the capacitor's terminal. But the parallel resistors shunt that weak signal to ground so as to make the filter have a sharper curve at its cutoff region. A frequency more higher than this and it passes through the capacitor to the output, with the resistor having minimal effect on the signal due to the signal being strong. Because of this, the output of passive filters are always lower than the input. Now, with the explanation of the operation of the filters, it's time to make actual calculation for specific resistors and capacitor values that will give specific operation. In my example, I want to calculate values for the low pass filter, which will allow a frequency of 0 Hz to 500 Hz to pass to the output, and anything upward should be hopefully blocked. And I'll calculate values to use for the high pass filter too. Now to start with the low pass filter, using this formula I got the value of 38 nanofarads for the capacitor and 10 kilo ohms for the resistor. I hooked everything onto a breadboard and ran tests of the setup, and surprisingly the circuit started shunting the frequencies at around 300 Hz. So if you wanted to plot a graph on this, you would get a curve like this. Now moving over to the high pass filter side, everything on the breadboard still runs. Okay, now I did some tests on it and the wave was really distorted at lower frequencies. In all, the two filter setup just works fine. Using of inductors and other active devices like op amps will give your filter an advantage to really have a sharper knee curve at its cutoff region, so as to ensure optimal accuracy. Thank you for watching this video to the end, and you can support me through subscribing to my channel and liking this video. You can also support me through Patreon so as to help me in making more educative videos like this. Thank you and see you next time.